posting this video because there were a few that reached out to me with some questions about the homework. I just quickly wanted to walk you through what the homework is essentially asking for. So first of all, you have here 4 different parts of this question, right? So you have in problem 1 and problem 2, these are 2 separate problems. Problem 1 has 4 different questions. The first one is just a simple frequency table, just like we have done essentially with the volcano example. So essentially all you need to do is to copy paste this table into Excel, which is an easy thing to do, right? All of you know how to do that. And then you have this table in Excel. Good. So now you have price groups. You essentially want to create 1, 2, 3 groups, right? So you just need a grouped frequency table that basically has here range of prices on the header 10 to 14. Then you have 15 to 19, right? And 20 to 24. 24. Then the only thing you need, so basically you create the sum of all the quantities. So there's a sum. You know how to build the sum of the quantity of the shirts, right? But this is easy. We've done that. This is 3980. So the only thing you need to do is now you need to sum up the shirts from each of these categories. And that's as easy as it could be, right? Once you have this sum, that's your count of shirts. Then you have the proportion of shirts. And the proportion will have in the numerator this count, and in the denominator this sum of all shirts. Explicitly ask for all shirts. Then the proportion logically can also be transformed into a percentage. Good, easy. Now you need the incomes. The incomes is essentially price multiplied by quantity. So if you have an income with a certain price, you need to multiply it, the quantity with the price, right? And then all you need to do is using the quantity of shirts multiplied by the price. This is what that means. Now you use those incomes to calculate a mean income. So if you had here 3,340 and here 2,120 and here's 3,150 and here's 3,160 and 1,720, which are not real numbers, obviously. Only thing you need to do is you calculate the average income. And this is now this plus this, plus this, plus this, plus this, and plus this, divided by the number of entries, 1, 2, 3, 4, 5. No functions, don't forget, no functions. What to do again? Oh, this one plus too much, okay. Minus the plus. Okay, so this is how you calculate an average. And now you need something else. Now you need a standard deviation. The standard deviation is calculated by the deviation. Deviation is, as you know, income minus the mean. This is your mean. Don't forget to lock in the cells, right? That's your deviation. Then you need a squared deviation. That gets you to the variance, and then you need the average squared deviation, the average sum of squares, the average sum of squares. So this is sum of squared divided through the 5 entries gets you to the variance. The square root of the variance, this is SQRT var, gets you to the standard deviation, and you do that for all 3 groups. Okay. So this is mean. These are the standard deviations, 3 averages, 3 standard deviations. Notably, if you use a function, you lose points. So do the calculations just in that format. Good. Lastly, you do a bar chart. You can in histogram. So you do a bar chart of these of the groups. So you do a bar chart of these average incomes. Okay. So this average income, this becomes the bar chart. Bar chart. Then you want to do a scatter plot. And the scatter plot is to be done for all the prices. So this is, we want on the x-axis, we want the prices. On the y-axis, we want the income. Okay. Quantity, oh no. So we will quantity, okay, so income, actually, if you would have done income, I wouldn't have taken points. So you need quantity and price. So what you need to do for that, you need to change the order as we have done, right? Because the first entry is always going to be the x-axis. You just change the order. You just change quantity after price. You invert the order. And then you basically get, as a consequence of that, you get essentially easily calculate the scatter plot just in the fashion we have done. Good. Make sure you have all these steps in there. Now you just need to scatter plot. You go on insert, scatter plot. Here's the scatter plot. Do a little bit of static work, fit the trend line, include trend line and the formula, just like we did in class. Add the axis titles, axis labels. All of this will go into the rubric and will be created on. So then you have sheet 2, which is problem 2. Please create a new sheet, otherwise it's getting too messy. So same thing. This time you have 4 variables. And this is the first time you're really doing something with data. So you essentially, you go now, you copy this over, just in the same fashion. You have this now in your Excel. You have 4 category, 4 variables. You have employee ID. You have the age of each employee. You have the time needed for the assembly of that kitchen unit. I chose an example like that because it's 2 absolutely separate examples, and I just wanted for you to also realize that there's essentially clearly a ubiquitous use of statistics. So no matter what you will be doing, no matter what field you're going into, statistic will always be needed. So now what you have this time around, it's 1, 2, 3, 4, 5, 6, 7 groups. So you want 7 groups, right? So you do 40 to 49, 40 to 49, 49, and you build nominal categories. You build a categorical variable, which is here essentially. That comes back to some questions that came up now in the discussion board. So this is basically age range. It's 40 to 49, 50 to 59. This is 60 to 69. So you have these different age ranges. Now you want to have the count for all employees. So how many employees do I have that are between 40 and 49? Keep in mind, sort your data. Otherwise, it's going to get complicated. Sort your data. Column is going to be age. We want to sort it smallest to largest. Make sure that my list has headers is clicked on. Otherwise, it's going to sort your header down. So now you have the age groups, right? So you have, oh, you want to actually sort it the time. Oops. Okay, data. It's been a while that I developed that question. Okay, so sort by time. So you want to do time now. Okay, same story. So how many do you have between 40 and 49? That's 1 and 2. So that will be 2. So now you have 55. That's just 1. 63. And then you basically go up until you have all summed up. And all you need to do is like then you do the same story. So each of these entries is 1 employee. Then you have the proportion of all employees, and the number of employees here is to be evaluated as count, because it's a count of patients, a count of employees, right? So it's 18 employees. So if you have 2, you know how to calculate proportions, right? You have a count, you have a proportion, you have a percentage. Don't forget with percentage, you need a unit. Percentage is a unit, percent is a unit. And then you calculate the age entries. So how are you going to do that? That's fairly simple, right? So all you need to do is, once you have a mean age and you have those 2 employees, you just need to say, okay, so this is equals, so which are the 2 equals this and this. So this is the first group, right? There are only 2 that did solve this kitchen assembly in less than 50 minutes, between 40 and 44. So it's 2 divided by 2. That's your mean. Make sure you do the calculations again, and then you have you need 7 averages. So this is average number 1. So you need 7 of these. Then you need the standard deviation. Standard deviation again is only calculated for these 2 individuals. So you basically you have here standard deviation, which is here the age of that 1 employee minus the age of the mean. So minus the mean age. So this is your deviation. Now you need your deviation. You need your squared deviation. Squared deviation. Then you need your sum of squares. And the different, the average sum of squared will become the variance. So essentially now you essentially get to the variance level, the square root gets you to the variance, gets you to the standard deviation. And you do that for all of these 7 groups. And you all put it in one table, neatly organized like this. Now you do the same story, you do a scatter plot. You do a scatter plot where you basically have on the y-axis time, and on the x-axis you have age. So now what does that mean? You essentially, you need to invert it again. Time is, oh no, you actually don't. This time you just can do scatter plot, right? So you only need to go on insert, data, and scatter plot. This is your scatter plot. Make sure you have all the calculations. Make sure you do all these steps here. Now you have time needed and x-axis. So label the axis. Make sure it's a neat, presentable scatter plot. So what do you essentially see now in this relationship? So once you have a scatter plot, and we talked about the interpretation of a scatter plot, right? You just need to go look what the data shows you and write the interpretation down, labeled as question 3. So just write this somewhere. Preferably you do it on the Word document, that you submit the Word document and that Excel sheet. That way you did all the calculations. Now you do the same thing for male and female employees separated. And I personally, I would recommend to kind of create a separate table. Just for the sake of this makes it maybe a little easier for you, otherwise you're getting mixed up. So you copy this in, you go on insert data, because sometimes when you sort, then your calculation may get screwed up. So copy it on a separate table. This is all that this is again one of those examples where Excel is just a little bit more tedious. So just sort it by age and gender. If you sort it by gender, you will automatically get this sorted in females and males, and just create the same scatter plot again. You go on scatter, you go on scatter, and you basically select whatever you want to have in that scatter. Okay. Yeah, and now essentially you test this in male and female employees separately, and you compare the conclusions from question 3, where you draw a conclusion about the relationship between time needed and age. Good. So this is all the homework needs. This is super simple, right? Have fun with it. See it as a good example, as a good practice of how to essentially do analysis in real life. All right. Have fun. See you in class.